Hello everyone. In this lecture, I would like to explain the banker's algorithm, in which this algorithm takes the assumptions in which we have the n processes and m resource types, and this algorithm makes the use of various data structures like available, maximum, allocation and need matrix. This available is of the dimension m, and this maximum matrix is of the dimension n by m, and this allocation matrix has the dimension n by m, and this need matrix has the dimension of n by m. This available means that what type of the resources are available for which type of the processes. This maximum is explaining to us that what is the maximum requirement that each resource will take of the processes. This allocation matrix will tell us how many resources can be allocated to the various processes, and this need matrix is the maximum requirement, future requirement can be taken by the different processes to be allocated. Now, if we are concentrating on the algorithm of this, then we can classify that if the process Pi requests some resource, then the two cases arises here. Then if the request is less than the need, then go to the step 2, else the error will be there. And if request is less than available, then go to the step 3, else wait condition. That means if the request is less than the available, then the system can grant the processes or resources immediately to the different processes. If available, then the matrices will change according to this. Available equal to available minus request, allocation equal to allocation plus request, need equal to need minus request. This we will further see in our example, that how can we implement this algorithm mathematically. Then if these conditions will be met, then we can take the assumption that system can grant the resources immediately to the processes which request the resources less than the available. Then if this new state is safe, then the safe sequence exists, and if the processes are not in the different state, then we can say the state is not safe. Then we are coming on to the safety algorithm of this. Safety algorithm means then we are taking the use of two vectors here, work is equals to available and finish equal to false. This available is allocated to the work by the new name, but it is the allocated resources that we are taking as the work. In the second step, find an I such that finish I equal to false. It can be initiated to false. Here we are also initiating this finish as false, and here also we are initiating this finish as false, and need is less than the work, and work can be taken as the available that we are taken as the previously vectors. Then if no such I, then go to step 4, and work is equals to work plus allocation. That means we can take available equals to available plus allocation in the third step. If we find the I, if we find the proper I, then we can take the work equals to work plus allocation, then finish I equals to true. Then in that case, the finish, if we are finding the I, then finish I will be taken from false to true. Then go to step 2. If the finish I will be taken as true for all the cases, then we can take the system is in the safe state. That means we have to check into the different loops that where that I occurs, and that if the I occurs, then we can take the sequence as safe for all the processes. Now we'll like to see the mathematical implementation of this algorithm through some numerical. Then if we are having A, B and C processes, and these are having the resources 10, 5 and 7, these are the instances of the resources that we have in total, and we are having the 5 processes, that is having P0, P1, P2, P3 and P4, right? So we are having this is in the tabular form, like we have the allocation matrix, then the maximum matrix, and then with the help of the allocation and maximum we can take the help to find the need matrix. Then if we are having the P0, P1, P2 and P3 and P4, then we are having some numerical, or you can say the rough example of this 0, 1, 0, 7, 5, 3. This is the allocation that we are doing to the process P0, and this is the maximum need that it will need in the future to complete its process. So with the help of this we can take the formula of need as need equal to maximum minus allocation. It can be taken as maximum minus allocation, and we are taking the help where we can take care of that each process x is less than equals to y. That means if the resource is not equal or equal to the resource that we are finding, then we have to take equal to of that process. Then that means 7 minus 0 can be taken as 7, 5 minus 1 can be taken as 4, 3 minus 0 can be taken as 3. Then 3 minus 2 can be taken as 1, 2 minus 0 can be taken as 2, and 2 minus 0 can be taken as 2. That means we are subtracting the maximum and allocation to find the need matrix. Then this is the 7, 4, 3, this is 1, 2, 2, this is 6, 0, 0, this is 0, 1, 1, and this is 4, 3, 1. Now we have to find the available out of this. Available we can take, then this is we can take the sum of this, then this is the 2 plus 3 plus 5 plus 2, 7. Its sum is 2, and its sum is 2 plus 1, 3, and 3 plus 2, 5. Then we can subtract this 7 to 5 out of this. So 10 minus 7 is 3. Available can be taken as 3. Available can be taken as 3. Then 5 minus 2 can be taken as 3, and 7 minus 5 can be taken as 2. So available that we have is 3, 3 and 2. According to this algorithm, we are taking the value, that is we are checking that we can serve this condition or not, or this process or not. According to the algorithm that we have, work is equals to available and finish equals to false. Then we are checking that process P0 332 cannot serve the need of 743. So we are taking the work is equals to 332 and finish as false. It will be taken as false because we cannot serve the P0. We cannot serve P0. Correct? Then we are taking the value 1, 2, 2. It can be served because 3 is less than 1. 1 is less than 3, 2 is less than 3, and 2 is equal to 2. So we can serve this process, and in that case P1 work is equals to 332 and finish is equals to false. Finish is equals to true. That means finish is equal to now true, and we are taking the work is equals to work plus allocation step. Work is equals to work plus allocation. That means this allocation is plus, can be plus to this available. That means work is 200, available is work is 332 plus this allocation, that means 200, and this is going to be 532. Now the available will become 532 instead of 332. Clear? Next we are taking that 532 cannot serve the condition of 600. Then 532 can serve the 011. Then 532 can be served as 011. Then we can take P3 work is equals to 532. Work is equals to 532, and work will be, final work will be 532 plus 211. So its value will become 3. Then this is 4 and this is 7. 743 is the final available. Then 743 can be served as 4 3 1. So we can say in this manner we can find the safe sequence. That means, for example, we can take the P1 as the safe sequence. First, that we are taking the safe sequence as P1, then we are taking the safe sequence with P3, then we can serve P4, then we can serve P0, and then we can finally serve P2. So this is the safe sequence that we are getting with the help of Banker's algorithm. Thank you.